Hi, in this video I'm going to talk about circles. I'm going to again remind you of things that you probably already know related with circles. So let's get started. Now, what do you already know? Probably. I guess you know how to calculate the perimeter of a circle or circumference, and that you know how to calculate the area. And maybe you know how to calculate arcs and sectors. So maybe you don't. So this is a part where we really are going to concentrate on. Now, do you remember these? Try to like stop for a minute, stop the video, think for a minute, and actually try to remember. See if you can write down what you remember of how these go. So circumference or the perimeter. So take any circle, and you take the perimeter of any circle, right? And you divide the perimeter of that circle by the diameter of that circle. You're going to get always the same number. We call the number pi, which is basically so that's why we say that the perimeter is 2 times the radius, which is the diameter, times pi. Here you have an example. This is the perimeter. In this case, the circle I've drawn, it measures 23.57 units. The diameter, which is this length here, measures 7.5. If I divide, I get pi. Now remember, the diameter is 2 times the radius, which is why I get the perimeter divided by 2 times the radius is pi, therefore pi times 2 times the radius times the diameter gives me the perimeter. That's where this formula comes from. Pi is simply the ratio, and it's constant for any circle. And it has, sure, it has like 3.14159. But the important thing about pi is that it's the ratio between the perimeter and the diameter. That's what really matters. Now, the length of an arc. Well, take this circle here. The whole measurement of the perimeter I'm going around with my red dot is going to be 2 pi r. Well, you know that, we just saw that. What if I want to know the ratio exclusively of this arc? We call it the arc. The line that goes from B to C. How long is that line? Well, we can simply do the following thing. You see, whatever that measures, whatever that arc measures, is the arc that corresponds to the angle that goes between AB and AC, this angle of 71.57. Because picture now that I'm at point B and I start moving around. Well, the angle will be getting bigger, 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 bigger. And by the time I get back to B, I have gone around 360 degrees. So what I'm doing here really is I'm saying, well, whatever the arc measures is whatever corresponds to 61.57 degrees, right? It's the same proportion as the circumference, the whole circumference, which is going to be 2 pi r, is proportionate to 360 degrees. You see, I'm doing it here the Spanish way. This is very similar to doing a regla de tres like this, okay? Now, if you want to think of it in other ways, the ratio between the length of the arc and the length of the whole circumference is equal to the ratio between the angles, 71.57 divided by 360. Now the circumference, as we said, is 2 pi r. It's going to be interesting later on. So that's how we calculate the length of an arc. If you want to think about it, this is simply comparing the proportions, or if you want to, if you happen to know this Spanish method known as the regla de tres, you can go ahead and do it. For the area, it's very similar. To calculate the area of a circle, the actual area of the circle is pi times r squared. A proof of that is slightly more complicated, so I'm just going to give you a good hint. Here's the circle. Now, if I want to calculate the area of this circle, think for a minute that this box that I'm drawing is r squared. You see, it's a square where its side measures the radius. So the area of this box is r squared. Now, try to realize, well, does it cover really this quadrant? No, it has this extra part over here. You see where I've got the pointer right now. That's not really included in the area of the circle. So how many of these squares would it take to cover the whole circle? Well, 4 would be too many, but 3 might be just too little. And indeed, the answer is that we need exactly pi of those squares. That's the exact amount of these squares that we need, which is why the formula for the area is pi r squared, just to help you visualize. Now, if I want the area of a sector, I'm going to do the same proportion calculation. Say, for example, I want to calculate the area of this sector, this pizza slice. I'm going to do the same thing. The area of the sector, the ratio between the area of the sector of this pizza slice, if you will, divided by the area of the whole circle is going to be proportionate to the ratio of this angle divided with the whole angle all the way around, 360 degrees. They're going to have the same proportion. If you want to do esa regla de tres, you know that the area of the sector is going to be your x, is to 34.63, as the area of the whole circle is to 360 degrees. And remember, the area of the circle is pi r squared. And that's how you calculate the area of the whole sector. Now, here's the interesting thing. I do recommend that you do some exercises on sectors and arcs, and just generally of sine, cosine, tangent, etc. At this point, you really need to. But it's important to face the next part to think of the following thing. Why are we using degrees? What's the deal with degrees? Why 360 degrees? It makes sense to you now, but it's a bit of a nuisance. Think about it. What we're doing here, we have the arc, whatever the arc measures, and we divide it by the circumference. And the circumference really is representing the whole circle, just like 360 degrees. But in this formula, I don't have a 360 degrees. In the sector, the same thing. Here I have pi r squared. But this denominator here, please think about it. This is representing the whole circle, just like this is representing the whole circle. But here I don't have any degrees. There's something a little bit strange here. Maybe I can simplify it. Here's how we do it. Well, I can simplify this formula. I can just take circumference over to the other side, which is 2 pi r, and I would end up with this. And for the sector, I would end up with this. But 2 pi r and 360, as I said, are representing the whole circle. So it's pi r squared and 360. They're just not in the same unit. So to simplify that thing, we're going to use something called the radians, which is really going to put angle measurement in terms of pi, which is exactly the one thing that is constant in every circle. And that will be something that is very useful. I hope you liked the presentation. I will see you next time. Goodbye.